Hello to all, welcome to the channel Money's Gate Tech Vision. In this lecture, I will solve GATE 2022 problems in the discipline of Instrumentation Engineering from the subject Electric Circuits. The topic is common for electrical, electronics and instrumentation. Solve the problem. So this is the problem given in the instrumentation paper. Here two circuits are given which is named as Circuit A and Circuit B. Circuit A and Circuit B. So here, what is the problem? The question is given circuit A with currents I1 and I2 are as shown. The current I3 in circuit B is dash. Okay. So here I1 is given as 2 amps and I2 is given as 1 by 3 amps for the circuit A. We need to find the current I3 which is given in circuit B. See the circuit, observe the circuit, the resistances are identical. All the resistances are identical. So here unknown resistance is only the R0 given in two circuits. So what I am going to do, I am using normal solution methods only, network solution methods only. Using mesh analysis, I will find I3. Okay. First I am taking the circuit A to find the unknown resistance R0. Then I am going to apply that R0 in the second circuit to find I3. Okay, what they asked, that I3 current. So first I am going to find the R0 value using the circuit A, and then I am going to apply the R0 value in the circuit B to find I3 current. So I am taking the circuit A. By using Kirchhoff's voltage law, I am going to write the equations. So first I am assuming, so here I1 is given for first loop current and I2 is given for third loop current. So I am going to assume the current for second loop as I. Okay, second loop current I have assumed as I. Let me write the equation for that. By using Kirchhoff's voltage law, for loop 1, I am going to write the equation. What are the resistances? R0 and 8. So R0 plus 8 into I1 is the current minus 8I equal to 16. And by considering here, what is the given value? I1 equal to 2 amps is given. So we can substitute for I1 in this equation. Now I am substituting I1 equals 2 amps in this equation. This equation will become R0 plus 8 into 2 minus 8I equals 16. So this is simplified as 8 into 2 is 16. 2 R0 into 2 is 2 R0. So 2 R0 minus 8I equal to 16 minus 16, which is equal to 0. Again it can be simplified as R0 minus 4I equal to 0. We need to find the value of R0. So for that we have to know current I. So let me write the second loop equation. Taking the second loop, by using Kirchhoff's voltage law, we can write the equation. So here assumed current is I and first loop current is I1. Okay, 8 ohms is the common branch and 6 ohms is the common branch for loop 2 and loop 3. Okay, what is the total resistance? 8 ohms plus 4 ohms plus 6 ohms. 8 plus 4, 12, 12 plus 6, 16. And so 12 plus 6, 18. So what is the value? So for loop 2, I am writing the equation 8 plus 4 plus 6 into I minus 8I1 minus 6I2 equals 0. Now I am going to substitute the value of I1 and I2 because I1 and I2 are given values. So we can substitute I1 equal 2 amps and I2 equals to 1 by 3 amps in this equation. So the equation will become 18I minus 8 into 2 minus 6 into 1 by 3 equal to 0. So here 6 and 1 by 3 it will get cancelled and it will become 2. This we can cancel and it will become 2. So the equation will become 18I equals 18. From this we can find the I as I equals 18 by 18 which is equal to 1 amps. So we have found I equals 1 amps. So we can substitute this I equals 1 amps in this equation, in the first equation to find R0. So 4 into 1 equal to 0. So R0 equal to, substituting I equal to 1 amps, then R0 equal to 4 amps. So now I found R0 equal to 4 amps. Now I am going to apply this unknown resistance value 4 ohms in the circuit B to find the value of current I3. Okay, I am going to apply the R0 value in the circuit B. For the next, in circuit B, I have applied 4 ohms in either side. in the place of R naught. Here one R naught and here one R naught. In the place of R naught, I applied 4 ohms. Now I am going to write the equations. Only here the given current is, whatever they asked, I3 is the current. So I3 is the first loop current. Now I am going to assume the current for the second loop and third loop. So see here, for the second loop, I have assumed as I3 dash. And for third loop, I have assumed as I3 double dash. For differentiating, I have assumed like this. So for the first loop current, I3, second loop current, I3 dash, and the third loop current, I3 double dash. Okay. Now we are going to write the equations for that. By using mesh analysis, we can use the Cramer's rule directly. Here I have written the equations first. For loop 1, by using Kirchhoff's voltage law, 12i3, 4 plus 8 is 12, 12i3 minus 8i3 dash equal to 8. So which can be simplified as 3i3 minus 2i3 dash equal to 2. And for loop 2 also, I have written the equation taking I3 dash is the current, and what 8 ohms is the common 8 ohms is a common branch for loop 1 and loop 2. 6 ohms is a common branch for loop 2 and loop 3. Okay, so we can take the currents as consideration and we can write the equation like this: minus 8i3 plus 8 plus 4 plus 6 is 18i3 dash minus 6i3 double dash equal to 0. So which can be simplified as minus 4i3 plus 9i3 dash minus 3i3 double dash equal to 0. This is second equation. And for loop 3, I have written again the equation. So what are the resistance? R0 plus 8 plus 6. Okay. So R0 is 4 ohms. Minus 6i3 dash plus 18i3 double dash equal to minus 48. Because assumed direction is in this direction. So it will flow from positive to negative potential. So positive to negative potential for the voltage source means we can represent it as negative only. Okay. So minus 48. So this can be simplified as, this equation can be simplified as minus I3 dash plus 3I3 double dash equal to minus 8 divided by 6 minus 8. So let me take this as third equation. So for explanation purpose, I have written the equations for 3 loops. You can apply the Cramer's rule directly itself. So using these equations, we can write the matrix equation using Cramer's rule. Using Ohm's law, R into R matrix into I matrix, that is equal to voltage matrix. So R matrix, we can write with the coefficients of currents. So what are the coefficients? In the first row, 3, 3, minus 2, 0. And here, second row, minus 4, 9, minus 3. And in third row, 0, minus 1, 3. This is resistance matrix. Into current matrices, first loop current is I3, second loop current is I3 dash, and third loop current is I3 double dash, equal to voltage matrices. First loop voltage rises 8 and second loop 0 and third loop minus 8. So this is the matrix equation representation by using Cramer's rule. So using this we can find I3. We can find I3. So to find I3 we need to find the determinant delta and also delta 1. Okay. So first let me find the delta using this matrix. Delta equals, determinant equals 3 into 27 minus 3 plus 2 into minus 2. So which is equal to 48. I found delta as 48. And to find the delta 1, the first column matrix should be replaced by the voltage matrix. What is the voltage matrix? 2, 0, minus 8. So in the place of first column, we are replacing by the voltage matrix 2, 0, minus 8. So now we need to find the determinant of this matrix. So I have denoted that as delta 1. Delta 1 equals 2 into 27 minus 3 is 24 plus 2 into again minus 24 equal to 0. Because 2 into positive 24, 2 into minus 24. So it will get cancelled and this determinant delta 1 equal to 0. Now we need to find I3. I3 is nothing but delta 1 by delta. So 0 by 48 which is equal to 0 amps. So answer I3 equal to 0 amps. Okay, for this given problem, you can apply reciprocity theorem and superposition theorem also to try for that also, and also you can apply the nodal analysis also to find the current I3. This is Mani's Gate Tech Vision. This is a channel for engineering competitive examination. You can subscribe with bell icon to my channel and you can view the lecture series regularly. Thank you very much for watching the video.